Good evening, sir. Can you hear me?
Yes.
Yes. Thank you.
Welcome.
Thank you, sir.
થોડા આવી જાય ને 50 આવી જાય પછી ચાલુ કરી દઈએ હે ને.
Sure, sir. Sure. તમારા મિત્રનું કેમ છો?
Okay. Good evening, all of you. So we are move forward 3, and today day 3. We have another 2 session. Interesting session. Session number 5 and session number 6. So session number 5 will be delivered by the Dr. Ujjaval Patel, and session number 6 will deliver by Dr. Bibas Ghosal. So our session number 5 speaker already joined us, Dr. Ujjaval Patel. I can see right now 61 participants also joined, so we can start now. Remaining will join us now. Brief overview, brief introduction of Dr. Ujjaval Patel. So Dr. Ujjaval Patel is working as an assistant professor in the School of Cyber Security and Digital Forensic, National Forensic Science University, Gujarat. Gandhinagar, Gujarat, which is the Institute of National Importance and handled by the Ministry of the Home Affairs in India. He has completed his BE Electrical from LD Engineering College in 2001, Master from Faculty of Technology, MS University in 2008, and PhD from Charuset University in 2019. He has 17-year experience, academic experience, and 3-year experience in industry. He has published, recently he has published one book, Futuristic Trends in IoT Added Numerical Relaying Scheme for Transmission Line Protections in 2021. He is reviewer of many international journals as well as national journals. He has published several research papers in the peer-reviewed international journals, and he has completed several online courses in NPTEL on Internet of Things. And he has also completed specialization in IoT from University of California, USA. His research area includes IoT security and forensic in smart grid protection and industrial automations. So with that, I welcome Dr. Ujjaval Patel. Please, sir, deliver your session.
Thank you, sir. Thank you so much. Sir, I am sharing my screen. Please let me know whether you can see or not.
Okay, sure. Yes. Screen આવે છે.
Is it visible? Okay.
Yes,
sir.
yes.
Okay, sir.
Yes.
Okay, so thank you so much, sir, for inviting me for this particular 5 days FDP on the Internet of Things and its applications. So basically, my theme of this particular talk will be the Internet of Things applications, and in this particular talk, I would like to mainly focus on to the IoT security, its challenges and best practices. I will also explore what are the IoT, we can say the research issues as far as IoT security is concerned. So this will be my presentation outline. So first of all, I will have a basic, I will start with the basic introduction, then we will see the application scenarios. And then in application scenarios, we will focus on to the basic IoT architectures, and then what are the challenges in each and every level. Simultaneously, we will also see some of the security concepts like how we can identify the different kind of attack surfaces. Then we are following as far as providing the security into the Internet of Things. I will be focusing on to the OWASP top 10 vulnerabilities. So what is OWASP top 10 vulnerabilities and how we can have its mitigation? So that I will be exploring in detail. Then we will see what are the best practices for which we should follow as far as the cyber security of the IoT devices has been concerned. And then we will see the research issues and the opportunities in this particular field. So first of all, what is IoT? So I hope majority of the participants have learned multiple definitions of the IoT, but I have made my own different kind of definitions of Internet of Things. So what is Internet of Things is if at any time, sir, participants can ask questions at any time, or we are allowing them at the end. Okay. So, if any particular participants are having any questions, I will be taking all these particular questions at the end. And if anybody is having any kind of questions, we will definitely answer all as many questions as possible. So what is Internet of Things is basically Internet of Things is nothing but it is a one kind of cyber physical embedded systems using which we can control anything from anywhere in the world. So using the IoT, we are controlling some physical devices using different kind of protocols. Multiple kinds of protocols are available, and sometimes we are controlling all these particular devices using wired protocol, and there could be some wireless communication protocol could be also be there. So we are controlling all these physical devices through different kind of communication protocols, and they are controlled using some embedded devices. Embedded devices are the devices which are nothing but a combination of hardware and software. If we are writing some software in some hardware like in microcontroller, and we are controlling some physical applications, then it is a one kind of embedded system applications. Our mobile device are also a one kind of example of embedded systems applications. So using the IoT, we can control anything from anywhere in the world according to our requirement. So we can control any kind of device. Any kind of device can be controlled, uh, and we can anybody can control, and we can also establish the different levels of control into the IoT. We can establish the director level control, managerial level control, supervisor level control, and other stakeholder level control can be established into the IoT. We can control anywhere in the world. For example, if nowadays some technologies are available, even if we are there in the middle of desert or in the middle of forest or in the middle of sea, then also we can control. How we can control? That is by using some satellite communications. So using satellite communications, we can control from anywhere in the world using these IoT devices. We can automate any kind of business, and multiple kinds of networks can be also be available. If one kind of network is not available, we can use another kind of network in order to provide continuous connectivity. So multiple kinds of network and communication protocol can be used. And we can have 24/7 control of all these kind of devices. So this is IoT is, we can say, in the era of Industry 4.0, we can consider IoT as a one kind of disruptive technology. Now, this is the one kind of example of conventional industrial automations which were prevailing at present. So in the conventional industrial automation, at the base level, there were different kind of sensors and actuators will be there. So all these sensors and actuators are connected with basically the PLC module. So whenever suppose this is one particular RTD is nothing but the resistance temperature detector. So RTD is basically used for sensing the temperature into the industries, like in furnace, we can sense the temperature using the RTD. So using the RTD, this particular RTD will convert that particular temperature into some voltage signals, and that voltage signals can be applied to this particular input-output module. So this module is working as a IO module. This module is called input-output module, means IO module. So this RTD will give the input to this particular RTD, input output module. And using this input output module is basically used for signal conditioning of these input signals. Means some basic filtering will be done, some noise will be removed from the input signals, and then that filter signal will be applied to some controller. In controller, we can write down the program according to our requirement. So for example, if the temperature is greater than 25 degrees centigrade, then if I want to turn on some AC, then the temperature will be sensed by this RTD. It will be converted into the voltage signals. These voltage signals we are applying into this particular IO module. It can convert that particular analog value into the digital value, and that digital value can be applied to the PLC. In PLC, we can read that digital value. We can write down the program for turning on the AC whenever the temperature is greater than 25 degrees centigrade. At that time, we can turn on some AC, and then that when for turning on the AC, output generated by the PLC can be applied to some output module. So some of the terminals of this input output module are working as a digital inputs, and some of the terminals are working as a digital output. So this digital output which is generated from the PLC is applied to the output module, and from the output module we can apply to some relay. right? And onto the secondary side of the relay, we can connect any kind of home appliances, or we can also connect some industrial appliances. So this is the basic architecture which were prevailing up till now. And basically for local monitoring and control, we can use the HMI, which is nothing but a simple LCD kind of displays, in which the full form of HMI is basically the human machine interface. So using the HMI, we can have the local control. HMI is basically used for local control of all these devices. So in the HMI, we can see the different kind of animation of the, for example, we can say the what is the liquid level, what is the current temperature, and we can also turn on and turn off using some button into the HMI. We can also turn on and turn off the different kind of processes. We can start and stop the different kind of processes from the HMI. So HMI is basically used for local control and monitoring. And if we want to have the central control and automation of each and every section of the plant, then we can use the SCADA. So SCADA is a one kind of software only, which is developed by the particular Schneider, ABB, Siemens. Now all are the basically the this kind of solution providers. So SCADA is a one kind of software only, which is basically use the supervisory control and data acquisition systems. So in the SCADA systems, we can have the supervisory control. We can monitor, we can see the trends, we can see the graphs, we can also make the data logging, we can print the we can say different kind of report, and all these kind of data analytics are also possible into the SCADA systems. In SCADA systems is basically used for central control and automation purpose. So SCADA is basically used for control of each and every sections of the plant. So each and every sections of the plant can be local control can be done by using the HMI, central control can be done by using the SCADA. So this kind of architecture were prevailing into the conventional industrial automation up till we can say 2010. But nowadays, uh, this is the scenario. Nowadays, these particular PLCs are also having some inbuilt Wi-Fi functionality. So inside this particular PLC, it is also having some inbuilt Wi-Fi facility. So this particular PLC can be connected with some Wi-Fi module, and from the Wi-Fi module, we can transmit this particular data which are available into the PLC. We can transmit this particular data through to some remote server. So this particular in this remote server, ThinkSpeak is a one kind of example of cloud infrastructure, which is basically owned by nowadays by the MATLAB. So ThinkSpeak is a one kind of cloud service. So in this particular remote server, we can store our data. So I can store my temperature, pressure, and all this data I can store into the remote server. Then in this remote server, I can analyze my data using their service. They are providing some software as a service or platform as a service. So using these particular services, I can analyze my data into the cloud, and I can also visualize the data into some web application, or I can also visualize that particular data into some mobile application. So from the cloud, I can visualize the data in my mobile, or I can also visualize my data into any web applications. Simultaneously, we can also have the bidirectional control. So here in this particular architecture, if whatever temperature is given by this particular RTD, this temperature will be, first of all, it will be there into the IO module, then it will be given into the PLC. In PLC, we can control the temperature according to our requirement, and we can generate some signal, and that signal can be applied to some actuator, which can be controlled by using some relay module. Local control we can have using the HMI. Central control can be done by using the SCADA. Nowadays, we can also make the remote control through some cloud platform, and we can also have some all these kind of trend graph, everything we can also see in our remote desktop or applications or into the mobile applications. And for that we can also create some VPN tunnel. So virtual private tunnel for security purpose, VPN tunnel can be used. So by creating some dedicated VPN tunnel, we can visualize all this particular data into mobile application or industrial applications, or we can say the desktop web-based application as well. So because of the, so here we can see that nowadays all this because of this we can say remote communication and control and automation, there are if we can control all these kind of devices from the remote place, but so simultaneously attack surfaces are also increasing. So if I want to make the cyber attack on any particular industrial infrastructure, then and there are multiple attack surfaces are also available. They are providing some wonderful facility. We can have the remote control, automation, all these kind of advantages are definitely there. But simultaneously, the attack surfaces are also increasing. So if attack surfaces are increasing, so what we should do? Shall we use this kind of automation? Yes or no? And so whenever there is any kind of challenges, this kind of any issues are there, that particular issue should be taken up as a challenge. And it should not be there that we should not use this kind of technology for this kind of reasons. We should have a strong mitigation and strong solution for this kind of technology, so that we can leverage the advantage of this kind of technology. So whenever we are doing the integration into the IoT devices, so which are the different kind of devices? So first of all, there will be some sensing and actuation of the. So first phase is the sensor and actuation level. So sensors are basically used, for example, RTD is a temperature sensor and actuation is nothing but the relay module. So sensors are basically gives the input to the controllers, and actuators are basically used for actuating some physical action. So sensor is a one kind of input device, actuator is a output device for the controller. So there will be the multiple kinds of sensor will be there, actuators will be there. All these sensors and actuators will be connected with some controller. So first is the sensors and actuator. Then after sensing and actuation, we are passing that particular information to the for the processing to the cloud. So for that we will be using some communication. So this communication will be done by using some networking devices. So communication will be so these networking devices are basically used for providing the connectivity, and then after providing the connectivity, we can transmit that particular data over the internet to some remote cloud, right? And into the remote cloud is basically used for information processes, and we can also have the smart communication between the different kind of components, right? And then into the cloud we can also establish the different level of data analytics, and we can also have the we can say the data communication in the mobile or web-based applications. So interfaces with humans means ultimately the mobile applications as well as web-based applications, right? So these are the different kind of components which we have to consider whenever we are developing some IoT-based integration. There, so in short, these are the different kind of components. So at the level zero, in IoT also there are different kind of levels are there, right? So at the level zero of the overall architecture, there are different kind of sensors and actuators are there. In the level one, there are this is the PLC is falling into the level one of the IoT architecture. So level one of the IoT architecture, basically there are the different kind of controllers are there. In level zero, there are sensors and actuator. Level one, there are different kind of microcontrollers. In level two, you can consider the local monitoring and control, that is HMI and the SCADA. Right. In level three, there are different kind of networking modules are there. Networking, we can say the devices are there. So there are multiple kinds of networking devices could be there, not only the Wi-Fi module. In industries, there are multiple kind of networking modules are there, like for example, firewall, IDS, IPS, multiple kinds of networking modules are available. So all these networking modules are falling under the level 3. Then level 4 is nothing but a you can consider as a this kind of servers. So all these kind of servers are basically falling under the level 4, and level 5 is nothing but the web or mobile application. This web or mobile applications are falling under the level 5, right? So level 0 to level 5, there are different kind of levels are there, and this kind of architecture has been proposed by the University of Purdue into the USA, and that's why this kind of architecture is called the Purdue architecture. So in the Purdue architecture, using the Purdue architecture, multiple kinds of applications are also developed. So here there are multiple kind of cyber physical system application scenarios are also there. So what is cyber physical systems? Into the cyber physical systems, multiple IoT devices are connected with each other and they are doing the coordinated data communication, right? So if we are using multiple IoT devices in any particular single application, using which we are doing some coordinated data communication, then whatever bigger systems we are communicating and we are automating, so that bigger system is called a one kind of cyber physical systems. So for example, smart city, smart healthcare, smart grid are some of the examples of the cyber physical systems. So cyber physical systems are not only used into the uh, conventional applications, but nowadays it is used also used into the defense application. Nowadays it is also used into the robotics. It is also used in smart aviation systems, and at multiple places it is used. So this is basically the Purdue architecture, in which at the level 0 there will be the different kind of sensors and actuator will be there. At the level 1 there will be the different kind of we can say the PLC will be there, right? So which are called the field controllers. And then into the level 2 there will be the HMI and the SCADA systems will be there. And then into the level 3 there will be the different kind of networking devices will be there. And into the level 4 there will be the different kind of servers will be there. And into the level 5 there will be the we can say web or mobile applications will be there, using which we can monitor as well as control through other kind of servers as well. So here we can between level 3 and level 4, here there is one another level is there, that is called the demilitarized zone. So what is plant DMZ? DMZ stands for the demilitarized zone. So here, from the level 0 to level 3, so these are the different levels which were available up till now. And because of this particular inbuilt Wi-Fi communication facility, we are connecting this particular operational technology with some IT technology. Level 4 and level 5 is falling under the information technology, whereas level 0 to level 3 is falling under the operational technology. So previously, this operational technology were isolated from the information technology. But nowadays, because of this kind of technologies like Internet of Things and other features into the embedded devices, this operational technology is directly connected with information technologies. So, in order to segregate the we can say the make the segregation as well as secured uh, of this particular operational technology from the IT technology is done by using some plant demilitarized zone, which is called the level 3.5. So level 3.5 is placed between level 3 and 4 in for the we can say the security of this kind of operational technology and the critical infrastructure which are available into the industries. So here, the major component which is used is we can say the one kind of data diode. So firewall is also used with the inbuilt feature of IDS and IPS, and IDS means intrusion detection system, IPS means intrusion protection systems. So if any kind of cyber attack will happen, at that time IDS will detect and IPS will protect, right? And nowadays this is the symbol of firewall. So using the fire nowadays, the firewalls are coming with a integrated capabilities of IDS and IPS. So using this kind of firewall, we can also detect the intrusion. That is, whenever any kind of cyber attack is there, then it can be automatically protected, right? So this kind of facilities are already available. Apart from this is the data diode. So using the concept of data diode, we can have the only unidirectional communication, either from and secured communication. Unidirectional and secured communication can be done by using this kind of data diode. Right? So the data will only flow in the single direction, and for that only we can say initial configuration shall be done into the data diode, and then the secured communication will be established between one particular sender and receiver. So basically, the firewall and the data diodes are extensively used nowadays for secure data communication into the industries. So this is the OT architecture with IT environment, and which is also called a one kind of Purdue model, which is used in the era of Industry 4.0 into the multiple industries. So this is the market of the cyber physical systems. So the market of this kind of cyber physical systems is also growing day by day. So according to this particular report by the data breach uh, and the Gardner report, it has been proposed that the market share of the particular cyber physical systems will be increased to up to US dollar 20 trillion by 2028. So the market share will be very, very huge in terms of the growth and the development for the cyber physical systems. So whenever we are using this kind of smart devices for controlling some physical infrastructure, at that time there are multiple attack surfaces are there. So which are the different kind of attack surfaces into the IoT, or we can say the larger cyber physical systems. So there will be the multiple kinds of sensors and actuator will be there. So first of all, there could be some sensor spoofing could be there. There could be some denial of service attack could be there into the sensor attack sensors, right? So we have to protect the sensors for the spoofing. So for that, tamper-proof sensors should be available, and the denial of service attacks can be also be protected by using some basically integrating edge level firewalls. So edge level firewalls can be also be integrated with the IoT devices into the and see in my research scholars are also working on an edge level firewall for the IoT devices. So that kind of edge level firewall can be also be developed, and it can be also be integrated in order to detect and mitigate this kind of DOS attack. After the sensors and actuator, the data will be communicated uh, by the communication modules, and in the communication modules, there could be the multiple kinds of attacks are possible. So, which are the different kind of attacks? That is eavesdropping means communication can be in eavesdropping. There are basically two kinds of eavesdroppings are possible. That is active eavesdropping and passive eavesdropping. In active eavesdropping, any particular intruder, any particular other intruder can sit, can be, we can say, intercept the data communication, and they can listen the communication in a active eavesdropping. And into the passive waste, and they can also modify the data, and they can also disrupt our system in active eavesdropping. Whereas in passive eavesdropping, they will only steal our data, right? So they will connect, they will be any intruder can be connected in our communication systems in the eavesdropping and passive eavesdropping, and then they will steal our data. Cannot modify our data into the passive eavesdropping, right? So that is the difference between active and passive eavesdropping. Then some packet insertion, spoofing, and modifications are also be possible. Then man in the middle attack like denial of service attacks are also possible into the data communication. and sometimes resource blocking means some by using we can say the encryption. They can some malicious script can be injected in our devices, and after injecting that particular malicious script, they can we can say the encrypt our data using some encryption algorithm, and they can ask for some ransomware, right? So some ransomware attack can be also be possible by making some resource blocking. So these are some of the very, very important thing in order to provide the security for the IoT devices. Then into the actuators also same kind of attacks can same as that of sensors. Some attacks are also possible into the actuator as well. So because sensors and actuator are the physical devices. So that could be some authentication at failure attack can be done, and some deadline missing means some threshold value of the temperature. For example, temperature sensor is there, then if the temperature, suppose there is one heating furnace is there, so in the furnace if the temperature is greater than uh, 25 degrees centigrade, I want to turn on my AC, right? So, such kind of scenario is there. But if sometimes by doing some attack, if I will modify that 20 threshold value 25 to 75, what will happen? The temperature will continuously increase from 25 to up to 75, and even our product can be damaged, our furnace can be blast, right? And so major disruption can be there if even though I am changing some single bit of information into using some attack, right? So if I am changing only single bit of information in my data packet, then major disruption can be happen in using this kind of technologies. So deadline missing means the changing of some threshold value and the manipulation of the status of the actuator. So that is called the deadline missing. Then that could be data will be stored either into some edge device, data can be stored into some fog device that is in local server, and data can be stored into the cloud. So storage of the data are possible at the three level. Number one, edge level. Number second, fog that is in local server, and number three, that cloud data storage is possible. So the storage modifications are possible, and then data we can say steal and modification, and we can say that the data will not be accessible for the intended user, which is called the data remnants. So data remnants is also possible into the by encryption of the data into the storage devices, right? So that kind of attack can be also be possible. Then next is the computing. So computing will be done. There are three kinds, as I have told. The storage are of three levels. Similarly, the computing is also of three level. So there could be edge computing can be there. That could be fog computing, and that could be cloud computing. Right. So edge computing means we are taking some data at the edge level, that is at the device level. So some critical data analytics should be done at the edge level. Some non-critical data can be done, data analytics can be done at the cloud level. So for critical data analytics, we can perform the edge computing. For non-critical data analytics, we can use the cloud computing, right? So we are using the different kind of computing. So if we are using the different kind of computing, then there could be if we are using some cloud computing or some edge computing, and by performing the different kind of attacks, some information leakage could be there, or there could be some enforced computing error can be done, or there could be some time synchronization error can be also be there. So we have to take care regarding each and everything whenever we are protecting our cyber physical infrastructure at each and every level. So we have to provide the security controls at each and every level. So what are the critical cyber physical challenges are there? So there are multiple kinds of cyber physical challenges are there. Some of the challenges are related to the security and privacy. Some of the challenges are there related to the complexity. Robustness of the system should be improved. Adaptability of the system should be there. Then coverage issue, that is network coverage issues could be there into the cyber physical system, which should be taken care. There should be some implementation cost, can be one of the challenge into the cyber physical systems. There could be some power constraint, and there could be some computation constraint. So if there is some security and privacy issues there, and there are different kind of attacks are possible. Some attacks are the cyber attacks, some attacks are the physical attacks. So these are the some of the cyber attacks, and these are some of the physical attacks. So for the cyber attack, our network defense mechanism should be very much strong. We have to protect our device, we have to protect our network, and we have to protect our cloud. So if we are providing the strong defense mechanism, and if we are providing some strong network segmentation, so first of all, network segmentation should be done properly, and then there should be some at in each and every segment, we have to provide strong defense mechanism. So how we are providing the network segmentation, and nowadays for providing the network segmentation into the industry 4.0 scenarios, there is a concept of zones and conduits. So we can explore what is the zones, what is conduits, and how we can provide protect each and every zone, and how we can pass the secure data communication using the different kind of conduits. Right. So what is zones, what is conduits? Therefore, that if you want to learn, then you can see the one of the industry 4.0 standard is there, that is IEC 62443. So IEC 62443 provide the right guidance for we can say the development of the this kind of infrastructure. So if we are following this standard, that is IEC 62443, then it gives the proper guidelines regarding each and every kind of network segmentation, and providing the security controls at each and every level in order to protect the cyber attacks, as well as it also provides guidelines for protecting against physical attacks. So we have to follow the standards and guidelines. The things are there, but it should be used properly. So if we are, what are the issues into the cyber physical systems? So in the cyber physical systems, up till now, I hope you are already knowing into, if we are knowing related to the IT side, then there is a CIA traits, right? CIA traits. So C stands for the confidentiality, I stands for the integrity, and A stands for the availability. So whenever we are using this kind of cyber physical system or the IoT based system, then we have to take care that CIA traits are maintained properly. If the CIA traits are maintained, if confidentiality is maintained, then we are maintaining the privacy of the each and every stakeholder. If the integrities are maintained, then we are integrity is mainly concerned with the safety. And if the availability is maintained, then ultimately we are providing proper reliability to our stakeholders. Right. So the confidentiality of the data and confidentiality of the particular user should be maintained properly. Right. And then the integrity can be maintained by the network level defense mechanism, and ultimately we can ensure the safety of the different kind of things and the physical infrastructure. And if we are maintaining the availability, then ultimately we have to maintain the availability of the different kind of services. And ultimately, by providing the availability, we are providing the reliability into the IoT based environment, right? So in short, whenever we are developing some cyber physical systems, at that time the main issues are in order to maintain the confidentiality, integrity, and availability of the systems. If we are maintaining this CIA traits properly, then we can ensure the trust and resilience architecture for our systems. So here, whenever we are providing the cyber security into the cyber physical systems, then we have to protect our equipment, we have to protect our human infrastructure, we have to protect our physical infrastructure, and we have to protect our IT systems, and we have to protect our data. So that is the difference between the cyber physical system and the IoT. You may ask us, sir, what is the difference between the cyber physical systems and the IoT? So, as in cyber physical systems is basically the systems which concerns the security of all each and everything. Whereas into the IoT, we are making the secured communication of IT systems and secured communication of our data and the uh, controlling embedded devices. Whereas into the cyber physical systems, we are also focused with the security of equipments and security of human beings. So all these kind of cyber systems as well as physical systems should be protected from the different kind of risk. And if we want to protect the different kind of risk, then we have to find out the vulnerabilities, and for after finding the vulnerabilities, we have to find out its countermeasures. Then finding its countermeasures, we have to regularly update our guidelines. Each and every organization should also have their own cyber security policy, right? So each and every organization should have their own cyber security policy, which are called as guidelines. So these guidelines, in order to so these guidelines should be also be updated on a regular basis. So for updating these particular guidelines, we have to see the security controls from the humans, security controls from the equipment, physical infrastructure, IT, and data, right? So from all, each and every things, we have to find out the vulnerability, and then for so this for finding this vulnerability, we can perform the different kind of audit. So we can perform the different kind of audits for each and every kind of stakeholders, and then and entities, and then we can have the penetration testing of each and every kind of systems, and then we can find out the vulnerabilities. After finding the vulnerabilities, we should find out the countermeasures, and then we should update the guidelines. Simultaneously, we should also, out of these multiple kinds of vulnerabilities could be available. Some vulnerabilities could have the low level severities, some vulnerabilities can have the higher level severities. If some of the vulnerabilities are having the higher level severities, then that vulnerabilities can be considered as a threats, right? So if the vulnerabilities are having the higher level of severity, then it can be considered as a threat, because if that particular vulnerability will be exploited, our system will be disrupted. So that is considered as a threat. Threats can have the higher level of impact. So and for that particular threats, we should have the long term solutions. So we have to identify the critical threats without fail, and then we have to find out the solution for each and every threats, and then we must have to update our guidelines, and that guideline should be followed on a regular basis. So this kind of we can say the approach we should follow. So first of all, find, then analyze, then identify the potential risk, find out the countermeasures for this vulnerability, for low level severity vulnerability, high level severity vulnerability, find out the potential solutions, and find out the short term and long term goals, and then update our guidelines. So this kind of security approach we should follow, and ultimately we have to update our security policy on a regular basis. So there are OWASP top 10 vulnerabilities are there, which we should have in mind whenever we are protecting our uh, IoT based infrastructure. So in these are some of the OWASP. So from this particular slide, I am giving the acknowledgement to the OWASP only. So OWASP is nothing but Open Web Application Security Project. So this is the project which is basically taken up by multiple stakeholders, and then they are is a one kind of security alliance only. And using this particular OWASP is a one kind of organizations which regularly releases the different kind of vulnerabilities for the IT systems, for the OT systems, as well as for the IoT devices, and as well as for the mobile applications as well. So OWASP releases the top 10 vulnerabilities on a regular basis, and these are the top 10 vulnerabilities which were released by the OWASP into the 2014. So this is the presentation of the OWASP organization only. So I'm giving the acknowledgement to the OWASP organization only. So there are so these are the some of the vulnerabilities of the OWASP. So first vulnerability is the insecure web interface. So this particular from the IoT devices, we are sensing the data into the using some sensors. Then sensor gives that data to the controller. Controller sends that data to the, we can say, the networking device, and from the networking device, the data is communicated to the cloud, and from the cloud, we are sending the data to the web or mobile applications. Right, so if you are sending some data to some web or mobile application, then that particular web or mobile interface could be insecure. Right, so what are the critical obstacles? We should not use the default username and password. We have to provide the strong account lockout mechanism, and we have to check our web or mobile application with some critical vulnerabilities. So we should perform some XSS injection, CSRF injection, or SQLi injection can be done. And by performing this kind of injections, we can exploit the vulnerabilities. Ultimately, we are doing a uh, exploitation of the vulnerability is nothing but a simulated cyber attack. We are performing some simulated cyber attack under the controlled environment. So if we are performing some simulated cyber attack under the controlled environment, then it is called a penetration testing. So we have to perform the penetration testing. So for penetration testing is basically done for finding these vulnerabilities. And in the penetration testing, we have to do the different kind of injections into the web and mobile applications, and we can check whether it is infecting or not. Right, so this is the methodology, and these are the critical things which we should focus in mind. Then so what is the solution? We have to allow we should not allow the default username and password as far as possible. And if any particular devices are uses the default username and password, then it must be changed immediately. And we have to enable the account lockout mechanisms, and we have to conduct the web application assessment, that is penetration testing, on a regular basis. For example, there are multiple IP cameras are there, which are in majority case they are uses the default username and password. So there are multiple IP cameras are there which are uses the default username password. For example, 1 2 3 4 5 6 7 8. Right, so they are using this default username and password. So IP can be found from multiple sources. There are multiple tools are available. You can using which you can find out the IP of that particular camera. And if you can will try to connect with it, it will ask for the password. And if it is uses the default password, then anybody can be connected with that particular IP camera, and particular critical information can be stealed. So these are what some of the major vulnerabilities which are available in some of the uh, devices. So in short, we should not use the default username and password. The next vulnerability is insecure authentication and authorization. There is a major difference between authentication and authorization. Authentication means our username and password. So insufficient authentication should not be there, and authorization means the privileges. So if we are giving the different kind of privileges to the different kind of user, means we are authorizing that particular user for accessing that particular data or services. Right. So if we are, we should check whether that particular application is required that kind of authorization or not. For example, in our mobile, we are installing multiple application, and whenever we are installing any application, we are simply giving the different kind of permissions. But so some of the for example, if we are for example, let us take any particular payment gateway. So if there is any payment gateways are there, then the payment gateway does not require our microphone access and microphone access. They also, in critical case, only they require our we can say the camera access. So payment gateways are taking our microphone access. They are also, they can also take our camera access. So why they need it? right? So as and where they need it, we can enable it. So such kind of security controls can be established, right? So for that, in order to for in these vulnerabilities, what is the obstacles? We should not use the weaker password. We should use the strong password, and complex password should be used. Second important thing is the password recovery mechanism should be properly secured. So sometimes even before few days in well known, we can say the social media platform which all of us we are using at present as well. So in that particular social media platform, password recovery mechanism, if I am forgetting my password, then without asking for the we can say the multi-factor authentication, we were able to recover our password, right? So password recovery mechanism was not secured in that particular social media application. So such kind of major vulnerabilities are there, and because of this kind of vulnerabilities, the multiple accounts were already hacked before few years in that social media platform. So this is one of the major thing, that password recovery mechanism should be secured, and we have to enable the multi-factor authentication. So we have to provide sufficient authentication and authorization services if we are using any web or mobile application, even for the IoT devices. Then the some of the vulnerabilities are related to the networking infrastructure. So whenever we are using some networking infrastructure, we should not use the open port communication, right? So for example, by running some nmap command, we can nmap command, network mapping commands, we can see which are the ports which are open. So we can see that. So that kind of cyber security audit should be done. Okay, whether we are doing a data communication on a open port or closed port, right? So we should not use the unnecessary open port communication. We have to minimize the open port communication as far as possible. So the software port should not be open, as well as if we are using some hardware devices like we can say the Wi-Fi router or switch, then in that hardware devices also the open port should not be there, right? We have to lock, hardware locks can be also be there. So software port, open port should not be used. Hardware port also be should not be kept open, otherwise by anybody can connect their own devices even with our Wi-Fi switch in any open port, and they can also steal our sensitive information. So open port should not be there. Then uh, so there are some IoT devices are there which are the UPnP kind of IoT devices. UPnP stand for the universal plug and play. So you simply plug and play that kind of devices. So they are UPnP kind of devices are normally exposed to the internet using some open port communication, and they are also using default username and password. But yes, using this kind of UPnP kind of devices, we can easily inject some malicious script, and that malicious script can be injected in our server. That is one of the major thing, and the example of such kind of thing is a Mirai botnet attack. So in 2016, one of the major attack was there in many infrastructure, which is called a Mirai botnet attack, which were occurred because of this kind of UPnP kind of devices, which were using the default username and password, and they are using the open port communication. So if they are using some open port communication and the default username and password, then the botnet, major botnet attack can be conducted, and using this kind of IoT devices, malicious script can be injected in our server as well, right? So this is one of the major things which we should consider. As far as possible, we should not utilize the UPnP kind of devices in our critical infrastructure. So if our infrastructure is very critical, then we should not use the UPnP kind of devices. Then the network services are vulnerable for the denial of service attack. So our network services could be we can say the vulnerable for the DOS attack, that is denial of services. So that could be if in our network services, that could be multiple kind of flooding can be done using some tools, and our network services can be down, right? So for that, we have to review our network services for such kind of vulnerabilities. And for that, nowadays the multiple kind of intrusion detection system, that is IDS, and intrusion protection system, that is IPS, are also be integrated with the firewall. So firewall we are setting the basic rules and regulations, and which are basically used for the normal data communication. But apart from the this configuration rules and regulations, we can also integrate this kind of IDS and IPS capabilities into the firewall. So that is also one of the major thing. We have to use the firewall with the integrated IDS and IPS capabilities. The next thing is related to the cloud. So if we are using some cloud services, then there should be the transport level encryption should be there, right? So cloud services should, because we are sending and receiving the data from microcontroller to cloud and cloud to microcontroller into the IoT devices. So for that, we have to see that our sensitive information should not be passed in a plain text, right? So our sensitive information should not be passed into the plain text. We have to provide the SSL and TLS level security, and for that we can use some strong encryption protocol. Normally, some of the enterprises are uses the proprietary encryption protocols, which are not providing that much level of encryption. Right. So if we want to provide the highest level of encryption, then military grade encryption can be used. Right. So in short, we have whenever we are sending the data from the microcontroller to the cloud, at that time for the data communication, we have to encrypt our data communication between the microcontroller and the cloud, and we have to maintain our SSL and TLS layer, that is transport level security, can be ensured. And as far as possible, we should not use the basic encryption protocol. We have to use advanced encryption protocols. Then the next is the privacy concerns. And that if we are using multiple IoT devices, then some of the IoT devices takes our private data. For example, if I'm purchasing smartwatch, then if I am integrating my smartwatch with my mobile applications, then it is asking my username, password. So why smartwatch needs my username, password, everything? Right. So such kind of personal information should not be given to the IoT devices. Should not be fetched by the IoT devices. It is also fetching our for configuration purpose. It is also fetching our, we can say, the email ID, and they are also taking the access of our email. Uh, so if our smart devices, IoT devices are hacked, then anybody can listen my message, anybody can listen my email, anybody can listen my social media communication through the smartwatch. So such kind of scenarios are already there. Right. So by using sniffing simple smartwatch, we can read each and every kind of data of that particular person. Right. So such kind of things are already there. So privacy concerns is a major concern. So IoT devices should not collect too much personal information. And if the personal informations are collected, that information must be protected at proper places. And as far as possible, the end user should be given a choice for proper data collection. So these are the solutions. That is, we have to minimize the data collection. We have to once the data is collected, then that data should be secured properly. That is, anonymize the data, collected data, and give end user the ability to decide what data are collected and whether that particular data should be collected or not. All right. So this is the fifth vulnerabilities which is released by the OWASP. Then the sixth vulnerability is the insecure cloud interface. So if we are using some cloud services and using that particular cloud services, we are connecting our web or mobile applications. So in the web or mobile applications as well, there should be our strong authentication and authorization should be there. So that is the our sixth vulnerability. And the seventh vulnerability is related to the mobile interface. So if we are using some mobile interface, then in the mobile interface also there should be some authentication and authorization services should be there. And the eighth vulnerability is related to the insufficient security configurations. So if we are using some IoT devices, then we have to provide the strong password security options should be available, right? So making security logging should be available, and strong security options should be available into our IoT devices. Then there should be multiple encryption options should be available. Sometimes if we are providing some normal level encryption, then our data could be secured. But if we are providing higher level encryption, then our data can be have the highest level of security. So we have to provide the selection of the encryption options into the IoT devices. But it is a one kind of challenge for the developer. If they will provide the more, we can say, functionality, ultimately the cost of the IoT devices will increase. And because of minimization of that particular cost, they are selling their particular vulnerable product at a cheaper rate. See, if the product is cheaper, it could be higher vulnerability for the cyber attack. So no options to enable the security logging. So for making the security logging, they are providing no options. So we have to, for example, if my watch is has been connected with some other devices, then we have to notify the end users, right? So such kind of a security alert can be generated by that particular IoT devices. So if somebody external entity is trying to connect with my IoT devices, then that should be some mail or message or some calling even can also be done. So such kind of notification should be and alert should be generated for the user as well. The next is ninth is the insecure software or firmware updates. So majority case our data will be stored into the cloud, and into the cloud our updates servers are not secured. In majority case, the for providing the updates into the IoT devices, the different kind of servers are used which are called the update servers. So many a times it has been observed that update servers are not secured. So for that we have to secure our update servers, and for that the security certification should be available with the cloud service providers. So sign updates should be available. Then device updates transmitted without encryption. So sometimes if the cloud service providers we can say if they are updating our device, then that update is also done using without encryption, right? So first of all we have to verify the updates before installation, and we can say the update should be there with the proper encryption. And the device updates are not signed, so we have to secure our update server on a regular basis. So as far as possible, if we want to protect our IoT device at that time, we have to protect our software or firmware which is loaded into the microcontroller. And for that, nowadays in multiple IoT devices, over-the-air update features are also available. So whenever we are buying any IoT devices, we have to see whether the over-the-air update feature is available or not. If the over-the-air update feature is available, then as and when the manufacturer finds any vulnerabilities, they will try to patch it. And after patching it, means they will find out its mitigation. And once they are finding its mitigation solution, then they will release the updates, and they will try to update our device or using some over the air update facility. So if the over the air update facility is available, then only only we will be able to update our IoT devices. So this is one of the major concern for the IoT devices, that is secured firmware updates must be available into the IoT devices. So for that, over the air update feature should be available in our IoT devices. And last vulnerability is the poor physical security. So the physical securities are related to majority of all the IoT devices. So unnecessary port like the USB port or the SPI or the I2C communication port should not be open. So we have to minimize the external port, open port, we have to minimize. Access to the operating system through the removable media should not be granted. So using some removable media, it should not be able to access our operating systems of the IoT devices. So for that, we have to properly protect our operating systems into the IoT devices only. And inability to limit administrative capabilities. So many of the IoT devices are not having the proper capabilities to limit the administrative privileges. So for that, we have to limit our administrative privileges properly. So these are the top 10 vulnerabilities which are released by the OWASP. So what should be the best practices if we want to secure our IoT devices? So the first thing, as far as possible, we should not connect our IoT devices or in short, our device. Even I will also insist, we should also not connect our mobile with the public Wi-Fi. If we are moving on any railway station or into the airports, then we are getting public Wi-Fi. So if we are using the public Wi-Fi, then there could be very higher chances of cyber attack. So this is one of the major concern. As far as possible, we have to avoid using public Wi-Fi networks. Number one. Second, we have to, as for critical infrastructure, we have to use a virtual private network, which VPN tunnel should be used, which can make the security of our IP only, so that no one will, external entity will be able to identify our device over the network. Right, so we have to use the VPN tunnel only for secure data communication. Next is the, we have to provide our encryption whenever we are making the device communicated with the external world at that time, and the communication should be encrypted properly, so that even though if it is intercepted by the external entity like attacker, if attacker is intercepting our data, but if our data is encrypted, then the attacker will not be able to decrypt it properly. Right, so encrypting data ensures that even if it is intercepted, it remains unstable, unreadable, sorry. The next is we have to provide the strong authentication and authorization services should be there. We should not use the repeated or default passwords. This is one of simple vulnerability, but it is one of the major vulnerability. Because of this only, majority of, we can say the 80 percentage of the cyber attack, I can say 80 percentage of the cyber attacks are occurring because of this kind of vulnerability only. Because we are not using the strong password, we are using our outdated password and the default password only for securing, and because of which there could be some critical attack to our devices. Then we have to protect our devices with some antivirus and keep it updated. So if possible, we have to also install some edge level defense mechanism, which is nothing but antivirus kind of mechanism can be deployed in our systems, and then we can regularly update it for the new and updated viruses. Then, where, as far as possible, use a personal firewall with integrated IDS or IPS capabilities. Right, we have to use the personal firewall with integrated IDS or IPS capabilities. So firewall should be not shared with external entity, and it should have some higher end capabilities. Then, as far as possible, we should not click in our web or mobile application, we should not click on any shady or dodgy links, right? Which can be a one kind of malicious script which can be run in our device, and ultimately our device can be hacked in a very easier manner. So if you are getting some important data from the authorized party only, then only you should click on that particular link. Otherwise, you should not click on that particular link, because there could be the higher chances of cyber attack. Then we have to provide the proper education as well as training to our employees on a regular basis for the potential risk and the threats. And we have to explore what are the best practices for the secure data communication at each and every level. Then we have to download the apps only from the trusted parties like Android and the Apple stores. If we are downloading any applications, then we have to download it from the trusted parties only. Then as far as possible, we have to, if for encryption, data encryption, we have to use, as far as possible, we have to use the military grade encryption should be used. If we are using the military grade encryption, then it is a great way to defend against any kind of attack, we can say networking attack, and it will take attackers around 500 billion years to decode it. Right. So these are the some of the best practices which we should follow at the different levels, starting from the physical layer. Encryption should be there, authentication and authorization should be there. At the network layer, there should be some firewall and IDS, IPS capability should be there. At the cloud level, there should be encrypted data communication should be there, and again authentication and authorization should be there. So in short, if we are following our standard practices, and even there are multiple other concepts are also there, for which you can read, that is some of the standards. There are few standards are available for the IoT devices. For example, if we want to specifically read some of the international standard for the IoT device, then you can read the NIST guidelines, right? So NIST standards are available, which we can use it and as a guideline for securing our IoT devices. And if we want to focus on to the industrial IoT based secure communication into the industries, then you can also read the IEC 62443. Right. So these are the some of the standards which I will we can say the propose you for your future work. Right. So what are the future trends? So nowadays there are large number of integrations are going to be done for the IoT devices, and in these IoT devices nowadays optimization of the performance is done by using some AI or ML based algorithm. There is an increased adoption of the cloud-based cyber physical systems. So major systems are controlled using from the remote place. Uh, so they are called a one kind of cyber physical systems. And there is a greater focus on security and privacy should be there. And there will be the increased machine-to-machine communication will be there, and there will be the 5G integration will be also be there. In our NFSU, we are also having three center of excellence. One center of excellence in cybersecurity, and we are second center of excellence is in digital forensics, and third center of excellence is in the field of we can say the 5G security. So there are three center of excellences are there in which we are performing our research, innovation, training, and consultancy. So these are some of the research issues which I will propose, that is network intrusion detection for the IoT devices. Multiple methodologies are there. You can take up any one particular kind of architecture. So first of all, you have to define your architecture, you have to define your hardware architecture and the communication protocol. And then you can, because IoT devices are the heterogeneous devices. There are multiple kinds of sensors, multiple kinds of actuators are available, and each and every sensor, actuator, and the devices are using the different kind of communication protocols. So you can select at least one segment of that particular IoT devices which are extensively used. So you can select that segment, and in that particular segment, you can propose your own methodology for network intrusion detections, uh, and then you can also propose your IDS or IPS for IoT devices. Then you can also have the integration of the different kind of IoT devices with the zero trust architecture, and that also you can propose on a protocol specific manner. Next, you can also develop some IoT network miner, and you can also use these as a one kind of intrusion detection systems for the IoT devices. Then you can also develop multiple kinds of penetration tools for the IoT devices, which are so this kind of penetration tools are very less kind of penetration testing tools are available. See, if I want to check whether my IoT device is vulnerable for cyber attack or not. So we have to check at the device level, we have to check at the network level, we have to check at the cloud level. So all the levels we have to check it properly. And for that, IoT penetration tools are, we can say, almost not available. So we can develop some IoT penetration testing tools. Then risk assessment of the IoT devices is also one of the research topic in which you can find out the risk assessment, perform the audit, determine the severity level using some set rules and regulations, and then you can find out the risk score of the IoT devices, and then you can perform its mitigation for each and every kind of risk using some AI or ML based algorithm. So risk assessment for the IoT devices is also one of the another research issue. Malware detection for the IoT devices, there are multiple kinds of malwares are available, and for that, how you can detect the malwares for the IoT devices. Some of the malwares are undetected. For example, fileless malwares are the undetected malwares. So how you can detect that kind of malware into the IoT devices? That is also one kind of research issue. Blockchain added secured communication for the IoT devices is also one of the another research issue. SDN security, API security. Uh, so nowadays, majority of the networking capabilities are nowadays they are softwareized. So that is software defined networking concept are also there, in which we have to the central part is the SDN controller. So SDN controller is basically used to control the different kind of networking activity into the cloud infrastructure. Right. So we can say the SDN security is also one of the major research issue. API security from the cloud, you can send the data to web application or mobile application, and for that you can do some API based communication. So the for that each and every kind of API should be secured. You can analyze the each and every kind of APIs, and then you can find out some zero-day vulnerabilities in that APIs, and then you can make them secure. So these are some of the research issues. So thank you so much, everyone. If you have any kind of questions, then you can ask now. Thank you so much. Now we are taking up few questions.
Thank you very much, sir. Your very informative session and detail-oriented session delivered by you. I request to participants, please, if anyone have question, then they can write in chat box, or they can ask via raise their hand. So our programmer will unmute him or her for question, to ask any question. Hello.
Dr. Parag Shukla has raised their hand.
Mitesh. There is another question, feedback. Please see sir, chat box. There are.
Hello.
Am
I audible?
Yes, Dr. Parag Shukla. Please ask.
Okay. Yes. So, Dr. Ujjaval Patel, it's a wonderful session, sir. I have few
Thank you so
questions,
much.
sir.
Yes, sir. Yes, sir.
Yes, sir. Sir, I have one question that you explained well about the authentication and authorization, but what if authorized person authentication is released or it is said by authorized person? Then how we can prevent it?
Pardon, sir?
Yes, sir. Am I audible, sir?
Yes, sir. Yes, sir.
Yes.
So
Please
my
repeat
question
your
is,
question.
suppose, yes. If my, suppose I am an authorized person and my authorized person authentication privileges are shared with some other person, and if data breaches happen, then what happens, sir? How we can prevent this?
Yes, sir. So in that particular kind of scenarios, we can also have the device level integration for security purpose. So,
Okay, sir. And sir, what is the
ultimately,
difference between? Yes, sir.
yes. Ultimately,
And
that
sir, what is
particular
the difference between zero trust? Yes, sir. Okay,
If
okay,
yes,
sir. Thank you, sir.
yes, yes, sir. What is the difference between zero trust and
Uh, Zero trust and zero vulnerability. 0-day vulnerability.
zero-day
Zero trust
vulnerabilities are
threat. Huh.
both are completely different thing. In the zero trust architecture, we have to provide a proper network segmentation, and each and every segment of the network should be secured properly. And into the zero-day vulnerabilities are the unexplored vulnerabilities which could be present in that particular device, but it has not explored at present. So the individual vulnerabilities on that particular device which are not known to the particular manufacturer or even to the developer, but it can be exploited by the attacker. So that kind of vulnerabilities into the device level or the network level vulnerabilities is called the zero-day vulnerabilities, which are not explored, but it can be exploited by the attackers. And in zero trust architecture, we have to secure our each and every segment of the overall infrastructure properly.
Great, sir.
Yes, sir.
Great session, sir.
Thank you.
Wonderful. In 1 hour, 1.5 hours, you have explained a lot, sir. I think you have explained more than a book. Thank you very much, sir. Thank you.
Okay.
Thank you so much, sir.
Thank you, Parag Shukla. Okay. Anyone from participants, if they have question, then they can ask, or there is, please, sir, see the chat box. There is one question, Jaimala Pakare. Sorry. They are appreciating you. Okay.
Thank you so much, sir. Thank you.
Please unshare your screen, sir.
Yes, sir.
Hello, sir. Can you listen me, sir?
Yes, I can hear you.
This is Mohammed Mihan from Tamil Nadu, sir. Sir, if we are integrating this artificial intelligence, IoT, SCADA, what level of securities we can expect, sir?
Definitely, sir, we can expect the higher level of security, but ultimately it depends on the development, what level of integration has been done using the AI. And AI can be, see, AI is one kind of another disruptive technology which we can explore at each and every level of the security architecture. So it can be definitely used if we are using this prominent technology in a right manner, then definitely it can leverage our infrastructure.
Thank you, sir.
Thank you.
Any other question?
Okay. Anyone yet? Okay, sir. Nice session. And
Thank you so much.
they are appreciating your session via chat box. And after that, I will also share feedback sheet with them. They will fill their feedback about your session also. Okay, sir.
Yes. So thank you so much, sir. Actually, if any particular even audio from the audience as well, or even from your colleagues, if anybody is interested into the research areas into the field of IoT, then I can give the multiple topics, and then we can work together for better getting better outcomes. Thank you so much.
Well, sir, one group photo, sir.
Definitely.
Please, one group photo. I request to all participants, please turn on your camera so we can take one group photo with expert speaker. Please turn on your camera. I request to all participants, please turn on your camera so we can take one group photo. Okay, fine, fine. Please smile. I know you are coming from office, so how to smile, but during group photo, please smile. One minute. Okay, thank you, thank you.